Hey guys, what you'll see here is the review for section 8.4 to 8.6. And what I've done is, it is a front and back side of the worksheet. So I'm going to be doing 3 from each side. 3 from the simplifying side and 3 from the solving side. So if you take a look, these are the numbers that correlate to the problem. So in the first row, we're going to be doing problem number 3. The reason why I chose problem number 3 is because it's multiplication. Okay, because there are 3 different forms of simplifying. We can multiply, we can just simplify without any operations, and then we will add and subtract. Okay, so I'm going to try to do one of each. Okay, so number 3 is the first one, multiplying across. Now remember, this is not adding, so we do not need a common denominator. Because it's multiplication, we can just multiply the numerators and denominators. What I'm going to do first is I'm going to factor. Okay, so I'm going to factor to give me x plus 3, x plus 2, times the other quantity. Factor out of GCF here, 3 times x plus 4, all over x plus 4 and x minus 2. And because it's multiplication, I can multiply all the way across my numerators and my denominators. If you'd like to combine these into one common numerator, common denominator, please go for it. But in this case, we don't need to, because any factor in the numerator and denominator will simplify out just to 1, and then we're left with our final solution. Okay, so I have x plus 3 in the numerator times the quantity x plus 2 in the numerator. I have my 3, I want to put that out front. All over x minus 2. Okay? Problem number 4. This is a complex fraction. What I want you to do whenever you see these problems is rewrite this symbol as a normal division symbol. Because when some of you guys visualize that, it's easier to see. Okay, so I have my x squared minus 16 over x minus 3 divided by that bottom fraction there, x plus 4 divided by x squared minus 9. And now I'm going to factor and flip. Right? Remember that multiplication is the same as, or division is the same as multiplying by the reciprocal. So I'm going to get x plus 4, x minus 4, all over x minus 3, and then multiply by the reciprocal, x plus 3, x minus 3, all over x plus 4. And now just like the problem before, anything in the numerator can now simplify out with anything in the denominator because they're common fractions. So we have x minus 3, x minus 3. The x plus 4s simplify out, and then we multiply across. Okay, now you can leave it in factored form, so my final answer is x minus 4, x plus 3. Okay, this is where we struggle with a lot, adding and subtracting. Okay, number 9, notice how it is addition here. So now we do need a common denominator. Okay, so I'm first going to factor anything to see which we have. Okay, so x minus 2, that one can't factor. X plus 2, x minus 4, that one can't factor. This one can. Okay, so I get 16 minus 5x all over, let's factor this, x minus 4, x minus 2. Okay, and what you'll notice is that that third rational expression has the common factors x minus 4, x minus 2. And the first one only has x minus 2, and the second one only has x minus 4. So we've got to figure out how can I get the same denominator for each of my 3 rational expressions. So in this case, I need to multiply by x minus 4 over x minus 4. And that middle one, I need to multiply by x minus 2 over x minus 2. And now what you'll see is that all 3 have the common denominator. Okay, now what I need to do with addition and subtraction is combine all my numerators over this common denominator. So I'm going to need to multiply this out. Okay, so here's my first fraction, x minus 4 times the quantity x plus 1. If I multiply that out, I get x squared minus 3x minus 4. Okay, plus, if I multiply the second one out, x plus 2 quantity x minus 2, I get x squared minus 4. And then the third one is still the same, 16 minus 5x, all over my common denominators. Okay, so the common mistake that we made was that we totally got rid of denominators. Okay, that only works when you're solving equations, not when we're just adding to rational expressions. So now I need to add all my numerators together, because what you'll notice is they have the same common denominator. Okay, so if I add all my numerators together, x squared plus x squared, which is 2x squared. I have a negative 3x minus 5x, which is a negative 8x. I have a negative 4 minus 4 plus 16. Okay, so negative 4 minus 4 is negative 8, plus 16 is positive 8, all over my common denominator. So all I did was combine like terms in the numerator. And now I'm going to factor. What you'll notice is that numerator could be a lot easier if I factor out a 2. So I get x squared minus 4x plus 8. Oh, sorry, plus 4. Okay. And now let's easily factor this. I'm going to move down a second. So I can factor this numerator to 2's out front. X minus 2 times x minus 2 all over x minus 4, x minus 2. And what you'll notice is that one of our factors simplifies out, so we get our final answer. 2 times x minus 2 all over x minus 4. Okay, so I know this is tough, but these are the steps you have to follow. Get common denominators, add the common numerators together, combine like terms, factor, and simplify. Okay, let's flip it over here to the back side, which is our solving section. And now this is where all the denominators will go away because we're going to multiply the entire equation by the LCM. Okay, so the first thing I'm going to do is factor. X plus 2, x minus 2. So now what you'll notice is by definition, the LCM, the least common multiple of the denominators, is to make sure that all three denominators in this case are factors of this LCM. So in this case, x plus 2 times the quantity x minus 2 is our LCM. Because the first denominator, x plus 2, is a factor of it. The second one, x minus 2, is a factor of it. And obviously, x plus 2 times the quantity x minus 2 is a factor because it is it. Okay, so what I'm going to do is I'm going to multiply this entire equation by that LCM. Now, the reason why I leave it in factored form is so I can show you what simplifies out. I have to multiply this by all three rational expressions. So if I multiply by the first one, the x plus 2 simplify out. I'm left with this. Okay. The second one, the x minus 2 simplify out, so I'm left with this. And the third one, the entire LCM simplifies out, so I'm left with 17. So now I'm going to multiply out and simplify. If I distribute this, I get x squared minus 6x plus 8. Distribute that 2, I get plus 2x plus 4 equals 17. Let's move everything to one side because I have an x squared I need to factor. So I get x squared minus 4x plus 12, but then I subtract 17, gives me minus 5 equals 0. And let's factor. X minus 5, x plus 1 equals 0. So my two solutions are 5 and negative 1. And we always have to check our solutions. If I plug those back in, I do not get any common denominators of 0, so we're all good. Okay, let's go down to number 5. The LCM here. I don't really know what it is yet. So I'm going to factor. X plus 3, x minus 2. So now I know my LCM is x plus 3, x minus 2. And I'm going to multiply each of my terms by it. Okay? Now if I multiply the first term by x plus 3 times the quantity x minus 2, the x plus 3's cancel out, and I'm left with x times the quantity x minus 2. Subtraction, and I'll show you why this is going to be so important. The next one, the x minus 2's cancel out, so I get x times x plus 3 equals the entire denominator cancels out, so I get equals 10. Now the reason why this negative sign is so important is because we have a lot of people make mistakes here. You must distribute it to both terms. Okay, so the first thing, if I distribute, I get x squared minus 2x. The next, I get negative x squared minus 3x because the negative x distributes. So now let's move everything to one side. X squared minus x squared, well, that's 0. So I'm left with just negative 5x equals 10. And just divide by negative 5, I get x equals negative 2. Plug it back in, and it actually works. Okay, no zeros in the denominator. One more question here. Number 9 at the bottom. We got to find our LCM. Okay, in this case, it's x minus 6, x minus 1. Well, that works perfectly because both these denominators are factors of it. So let's multiply by our LCM. Okay, if I multiply the first term by the LCM, the x minus 1 simplify out, and I get 3x times the quantity x minus 6. If I multiply by the second one, the x minus 6's cancel out, and I get 2x times the quantity x minus 1. And in the third case, the whole LCM simplifies out, so I get 5x squared minus 15x plus 20. Okay, so we've done that, now let's multiply out. So I get 3x squared minus 18x. Distribute the 2x, I get plus 2x squared minus 2x. And this whole right side does not simplify anyway. So So now we got to move everything to one side and combine like terms. Ooh, this actually works out. On the left side, we get 3x squared plus 2x squared, and then if I subtract the 5x squared, I actually don't have any x squareds. Okay, so these actually cancel each other out. We're pretty lucky there. Negative 18x minus 2x is negative 20x. And if I add 15x, I get negative 5x. And then I'm going to keep the 20 on the other side. Divide by negative 5, I get x equals negative 4. Let's look up at the top, and it works. Plug in the denominators, and it works. Okay, so thanks for watching. I have one more thing for you. If you watched this entire video, I'd like you to please email me at cjkruger@barrington220.org. Just email me telling that you watched the video, you watched all 6 problems, and here's how it's going to work. If you email me and you show up to next Tuesday's review session before the test, I will give you extra credit. Okay, but the only way I will give you that extra credit is if both happen. You have to email me saying you watched the video at cjkruger@barrington220.org, and you have to come to next Tuesday's review session, which is the day of the test. Okay? Thanks, guys. Have a great day.